Hello, I welcome you all to your own channel MSK Learning. Now in this session we will see the green theorems. So we have one problem we'll do, and then how we know that how to verify the green theorems. So the problem on the screen, that verify green theorems in the plane for x square minus xy cube of dx plus y square minus 2xy dy, where C is a square with the vertices 0 0, 2 comma 0, 2 comma 2 and 0 comma 2. So these are the vertices of a square is given, and then one curve with plane is given for this, that is in the form of mdx plus ndy. So you have to verify the green theorem. So for green theorem, what is that the Cartesian form of the green theorem is nothing but mdx plus ndy is equal to line in surface integral of dou n by dou x minus dou m by dou y of dx dy, right? So here we can go and we'll do the solution. That solution you have, that you can write the Cartesian form of the green theorem is, the Cartesian form of a green theorem, right? So what is the Cartesian form of a green theorem? That Cartesian form of a green theorem is nothing but you have a m dx plus n dy is equal to surface integral over the region, that is dou n by dou x minus dou m by dou y, right, over dx and dy, right? So if you compare this equation with the given equation, so means this mdx we have to compare with the given plane, right? So the given plane is what? You can say that the given plane is what? That is over the curve x square minus xy cube into dx plus y square minus 2xy into dy. So if you compare this with the mdx plus ndy, so here we can go and we can say that m is equal to x square minus xy cube, right, and n is the y square minus 2xy. All right, then you have to differentiate partially with respect to y and x. So partial differentiation of dou m by dou y, right? So its partial differentiation is what? That is 3xy square, which is basically minus 3xy square, right? And partial differentiation of dou n by dou x, that is dou n by dou x, right? So it is nothing but the minus 2y, right? So minus 2y. So dou m by dou y and dou n by dou x we got, right? Now we have to go for the evaluation of mdx plus ndy over the curve C, right? So you can do here that evaluation, right, evaluation of what? That is mdx plus ndy over the curve, and the curve is nothing but the square is given with the four vertices 0 0, 2 comma 0, 2 comma 2 and 0 comma 2, right? So you can write one statement for better understanding, that to evaluate the given plane, that is over the curve x square minus xy cube into dx plus y square minus 2xy into dy, right? So we shall take the four different segments, right? So we shall take four different segment, right? And those four segment is nothing but we can say OA, right? On the OA, that y is equal to 0, right? Next you have a AB. On AB, x is equal to 2, and that next segment you have a BC. On BC, y is equal to 2, right? And the next segment is the CO, right? And CO, on CO, x is equal to 0, right? So these are the OA, AB, BC and CO. Means what? OA, BC, O is a square, right? So OA is one segment, AB is one segment, BC is one segment and CO is one segment. On OA, y is 0, on BC and on AB and what is called CO, right? X is equal to 2 and x is equal to 0, and BC and AB, y is 0 and y is equal to 0 and y is equal to 2. BC is y is equal to 2, right? Now that's why. Okay, now so if I draw the square for the given segment, right, so how the square is look like with the given vertices, you can see here that if you draw, so you can see that a square will be like that. Sorry, this look like a rectangle, right? So this is your y and this is your x, right? So this is the O, A, B and C. OA segment, right? On OA, y is equal to 0, right? And this is AB segment. On AB, x is equal to 2, right? This is BC segment. On BC, and y is equal to 2, right? And CO, on CO segment, x is equal to 0, right? So 4 segment we got. On all 4 segment we have to verify the we have to evaluate the mdx plus ndy, right? So first of all we'll choose the along, you can say first evaluation for the OA, right? So you can say along OA, means on OA y is equal to 0, right? So when you write down this given curve, right, so it is what I'll show you just one and then we can do like that. That is x square minus xy cube, right? And this is what you have a dx plus y square minus this is 2xy into dy, right? So on OA curve y is equal to 0, so you'll you have a y is 0, so this term will be 0, right? Y is 0, so this is 0, y is 0, this is 0. Only remaining is what? X square dx. So on the along curve OA you have a value is what? That it is varying from 0 to 2, is it or not? This is 0 and this is the 2, so you can say integration from 0 to 2 over x square dx, right? So its integration is what? That is x cube by 3 and the limit from 0 to 2, so it is nothing but you have 8 by 3. Let's say this is 1, right? So this is how you got that y is equal to 0 on this curve. So this y is 0, y is 0, so only x square dx is remain. Now you have a next curve is what? That is next you have a second you can write, that is along BC, right? So sorry, this is AB, I'm sorry, along AB, right? So on AB you have a x is equal to 2, right? So when x is equal to 2, it means that if you differentiate this with respect to x, so this dx will be nothing but the 0, right? So if this is your curve is given, right, that is mdx plus ndy, so in this equation dx is become 0. So when dx is 0, it means what? That means this whole term will be 0, so only you have a this term is remaining, and in this particular x you have to put 2, so this equation will become y square minus 2 into 2 is 4y into dy. Okay, so this is how we are evaluating the vertices, right? So this is over the what is that? Y square minus 4y into dy, right? And here the limit is changing from where to where? That is, if you see the AB, right, so it is varying from 0 to 2, right? Now so this is what you have a 0 to 2, so its integration is nothing but you have a y cube by 3 minus 4y square by 2, right? And the limit from 0 to 2, right? So when you put, that is 8 by 3 and this is 16 by 2 means 8, right? So it is 8 by 3 minus 8 is nothing but you have a 6 minus 16 by 3, right? So it is minus 16 by 3. This is the AB you got. Okay, this is correct. Y cube by 3 and 4y square by 2, that is 2 y square, and this is 4 into 8, right? Now you have a third vertices is what? Third vertices is nothing but the BC, right? So we can say along BC, right? So on BC you have a y is equal to 2, right? So when y is equal to 2, it means that further if you differentiate this, dy will be 0, right? So if you evaluate this the given curve, right, so in this dy is 0, so it means that this whole term will be 0. We have only this, right? And y you have to take 2, so it is what? X square minus x into 2 cube, that is 8x will be there, right? So you have to integrate finally, that is, and the limit is what? Limit is from that is 2 to 0, right? Why? Because this is your BC, right? That is BC is nothing but the x axis, right? So it is 2 here, x is 2, and y x is at this axis, x is 0. So that's why the limit is 2 to 0. Lower limit is 2 and the upper limit is 0, right? So now you can say the integration from 2 to 0 over what? That is, this term will be 0. Why? Because dy is 0 and y is equal to 2 you have to put. So it is x square minus 8x, right? So this is what you have, a x square minus 8x into dx, right? So its integration, you have a x cube by 3 minus 8x square by 2, right? And the limit from 2 to 0, right? So it is what 4 will become, that is x cube by 3 minus 4x square. So when you put the 0 to 0 minus, that is 8 by 3 minus this is what 4 and 4, 16, right? So 8 by 3 minus 16 is, and see here, that is when you take this values now, so it will become, so 0 minus, that means 40 by 3 you got, right? After simplification, this simple algebra, right? So now the final vertices you have, you need to come this, so the cycle will be completed, that is CO, right? So on this CO, that x is equal to 0, so further the dx will be you can say 0 only, right? So as the dx is 0, right? So this on this for this evaluation of this curve, the dx is become 0, means this whole term will be 0, right? And in this you have to take x is 0, means this is y squared dy you have to integrate, and then when you integrate, you are integrating the y vertices, means vertical axis, right? So this is varying from where to where? It is varying from 2 to 0, right? So now you can say that fourth vertices you have along CO, right? So on CO, what is that? That is x is equal to 0, so you have a dx is equal to also 0, right? So the evaluation you have to do only 2 to 0, right? And this is what y square dy. Why? Because whatever the x is there, that will become 0, and dx is also 0, so the first term mdx is 0, right? So now y square, this is what y square by this integration is nothing but you have a y cube by 3, limit from 2 to 0, right? So this is 0 minus 8 by 3, which is the minus 8 by 3, right? Now what we need to do, we have to find out the summation of, that is cyclic is there, right? So cyclic integral of mdx plus ndy, right? So you can say here that therefore cyclic integral of whatever the integration you have, x square minus xy cube dx plus y square minus 2xy dy, right? Cyclic means what? You have to add all the curve. So for along curve 1, right, along OA, along OA we have a 8 by 3, right? AB you have a minus 16 by 3 plus, right? And BC you have a 40 by 3, and CO is nothing but the minus 8 by 3. So your solution will be like that, that is cyclic integral of this is nothing but is equal to 8 by 3, right? And minus 16 by 3 plus 40 by 3, right? And minus 8 by 3, right? So if you see this and this will get cancelled, on simplification we'll get this value is nothing but the 8, right? Means cyclic integral of mdx plus ndy is equal to 8, right? So now you have, what you need to do, you have to find out the evaluation of dou m by dou n by dou x minus dou m by dou y into dx dy, right? So now we can go for the, now we have a next evaluation of is what? Evaluation of, you can say evaluation of what? Surface integral of dou n by dou x minus dou m by dou y into dx into dy, right? So now it is ranging from where to where? That is x is ranges from 0 to 2 and y is ranges also from 0 to 2. So you have to integrate from 0 to 2 and 0 to 2. Dou n by dou x we already calculated. So dou n by dou x is nothing but you have a minus 2y, and dou m by dou x, dou m by dou y you got, that is minus 3xy squared. So minus minus will become plus. So this is what? 3xy squared, right? Into dx dy. is it or not? First you have to integrate with respect to dx. So it is what? This is minus 2xy, and this is the plus 3x square y square by 2, right? So this is what you got. That is, you know, the simple integration is there. That is, one integration is still remain 0 to 2. Its integration is nothing but minus 2xy, right, plus 3 by 2 into x square y square, right? And the limit from 0 to 2, and this dy I am leaving as it is, right? So when you substitute this limit, so 2 x is equal to 2 you have to put. So this is minus 4y, and this is what you have a 2 to the 4, and 2 will get cancelled. So 6 y square, is it or not? So this equation will further simplification, means after putting this limit you will get the integration from 0 to 2. This is what you have a minus 4y, right? And x is equal to 2 you have to put. So this is 4 by 2, that is 2, and into 3 it is plus 6y squared. Again you have to integrate with respect to dy, right? So its integration is what? Minus 4y squared by 2 plus 6y cube by 3. So limit from 0 to 2. So this is 2 and this is the 3. So its simplification is what? That simplification is minus 2y squared plus 3y cube, right? 0 to 2. So now when you simplify, means you have to put 2 to the 4, 4, 8 minus 8, right? Plus this is 8 into 3. So this is what you have a 2 3 minus 8, and wait, this is 8, sorry, this is 2 is there, right? So this is the 2y cube, so it is 16, right? Minus 8 plus 16 is nothing but the 8. So now we need to check that from that 2 evaluation you can say that cyclic integral of m dx plus n dy is equal to surface integral of dou n by dou x minus dou m by dou y, right, over dx and dy is equal to what? Is equal to 8. So we can say that hence the Green theorem is verified, right? It is verified. So this is how you will do the problem. Thank you.